Yes, sir.
Fine. So as I was talking about the electrons which are other than 3D. Why other
Yeah.
than 3D? Because we have to calculate the status constant for 3D electrons. So other than 3D electrons, how many electrons are there? 2 plus 8, 10 plus 8, 18. So other than 3D electrons, how many electrons are there? 18 electrons are there. So now see, these 18 electrons into 1. These 18
Yeah.
electrons into 1, there is 18 into 1. And out of this 3D 10, you'll be leaving 1 electron. What rest is? 9. So 9 into 0.35.
Sir, why are
9
we
into,
leaving?
huh?
Why are we leaving?
See, what is the meaning of screening? What is the meaning of shielding? Pushing, na, repulsion, na.
Yeah, pushing. Yeah,
So
yeah.
repulsion between two group of sets of electrons, na.
Mm-hmm.
If you'll be taking all the 10 electrons,
Yeah.
then the repulsion will be there on which electron? No electron will be left over,
No
na?
electron. Yeah, yeah.
So one electron will be left over, so that repulsion between that one electron and rest of the electrons can be calculated.
Okay.
So 9 into 0.35. If we'll simplify this, what we will get? 21.15. So Z asterisk is equal to Z minus Slater's constant. What Slater's constant is? 21.15. 21.15
So it's denoted by that.
minus 30. No, what you are saying?
This is the latest constant.
Yeah,
Is it denoted by Z?
yes. This is latest constant sigma.
Okay. Yeah.
So 30 minus 21.15. So what you will get? You will get, you will get, I think 8.85. 8.85. See what it was here, 4.35. So here string constant will be less. ENC, sorry, effective nuclear charge will be less. And there, in this case, effective nuclear charge will be more. In this case,
Yeah.
effective nuclear charge will be more.
More.
So effective nuclear charge will be more. So size will be small. This will be having, this will be having 8.85. This will be having 4.35. So since here screening effective nuclear charge of ENC is more, so this will be smaller in size. Means 3D electrons will be more closer to the nucleus than 4s. 3D will get
Yes.
attracted more towards the nucleus than the 4s electrons. 3D will get attracted more towards the nucleus than the 4s electrons, because 4s electrons are having less effective nuclear charge than 3D electrons. So 3D will get attracted more towards the nucleus. Is it okay?
Yes, sir.
Now see what next is. This was very important, very difficult too, and rare to get it.
Mm-hmm.
So you should practice that too.
Okay.
Size of atoms and ions. See,
Standard what, sir?
size of atoms and ions. This
Okay.
is written
Yes, sir. Yes, sir.
size of atoms and ions. Size means two-dimensional. Length into breadth is size.
Yeah, yeah.
Two-dimensional. Length into breadth, that is size. Now see,
Mm-hmm.
this is first period, this is second period, this is third period. So when you go down the group from top to bottom, atomic size or ionic size both increases. Both increases. But while going across a period from left hand side to right hand side, ENC increases, effective nuclear charge increases, nuclear pull increases, nuclear attraction increases. So the size of the ions and size of the atom decreases. So this is already discussed now. Now see, radii also is done. Radii also is done.
Mm-hmm. Yes, sir.
Radii of the atoms and ions are typically in the range of 70 to 400 picometer. 70 to 400 picometer.
Kilometer.
So
Yeah.
Now see,
Mm-hmm.
this is already done. Metallic and crystal radii is done. Then covalent radii is also done. I explained you this all. This is van der Waals radii, and this is covalent radii, and this is crystal radii. Fine. So this all is already done. So definition in words, it is written here, which I have already explained you. This all I have already explained you, but still if you have any difficulty, you can ask me. Covalent will be the minimum and van der Waals will be the maximum, and crystal will be greater than covalent and will be lesser than the van der Waals. Fine. Van der Waals. What van der Waals radii is half the distance between two atoms. Half the
Yes.
distance between
That
the
will be two
nuclei of the
atoms.
two atoms. That is called van der Waals radii.
So it's the average, right?
Yeah, average. You can say average between the two
Okay.
atoms. If those two atoms are physically bonded,
Physically,
if
yes, sir.
those two
Physically
atoms
bond.
are physically bonded, then van der Waals radii. If chemically bonded, covalently bonded, covalent radii. And if it is in a crystal lattice, then it will be crystal radii or metallic radii. Fine. So crystal
Yes,
or
sir.
metallic radii, both will be same. Now see, see here on your personal device, you can zoom it and you can see it properly. Obviously, these notes are there with you only, so you can check it, and there you can get a clearer view of this table. See here, this is the smallest, bigger, 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 biggest. So on moving down the group, size increases, radii increases, volume increases, all 9 properties which I gave you there in the previous screen. So,
Yeah.
and when you move across a period from left hand side to right hand side, this is the biggest one, biggest, then a
Yes.
smaller, 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 and this will be the smallest one. This will be the smallest one. So when you move across a period from left hand side to right hand side, then this atomic radii, ionic radii, covalent radii, all these 9 points which I discussed there in the previous slide will increase, sorry, will decrease. And while going
Hmm.
down the group from top to bottom, all these 9 properties increases. So this all is already done. This all is already done. This all is already done. Now see, what next is? Again, the same thing here, periodic trends in atomic size. This is already explained. Ionic radii is also done. Ionic radii is also done. Now see, here I'll explain you this.
Yes, sir.
See, if you'll be taking sodium, sodium plus and sodium minus.
Mm-hmm.
See, in IT JEE, they will be giving you Na minus. Na minus is not possible now. Metals can't be negatively charged.
Yeah,
Metals
yeah.
can either be neutral or can only be positively charged. But this is what IT JEE advances. See, your age is 16 years. Your father's age is 50 years. So how old
Yeah.
your father than you is 34 years.
Yeah.
And how old you then your father is?
How old?
How older you are than your father is?
I understand, sir.
Minus 34 years. You are elder than your father,
Oh, okay.
minus 34 years.
Yeah, okay.
And your father is 34 years older than you.
Yes, sir.
This is what IIT JEE advances.
Okay.
They will be giving you Fe2 minus, Fe1 minus, which practically won't be possible.
Yeah, yeah.
Fine. So like this you should be. So here, see, first you'll write here protons. First you'll write here protons, then electrons. In all the three cases, protons will be 11 because you can't make any changes there in the number of protons or neutrons. In chemical reactions, you can't make any changes there in the number of electrons, number of protons and neutrons. Number of electrons only can get changed. Now see here, how many electrons are there? 11. Here, how many electrons are there? 1 you have taken out now, so 10. Here, how many electrons are there? 12. More the number of electrons, more will be the shielding effect. Lesser will be the effective nuclear charge. Lesser will be the effective nuclear charge. Bigger will be the size. See here, protons are not the deciding factor. Na? Here, protons are not the deciding factor na? Because they are same everywhere.
Yeah,
So
yeah.
on that basis, you can't compare their size. Then on what basis you can compare the size? Electrons. More the number of electrons, bigger will be the size. So this will be the minus will be the biggest in size and plus will be the smallest in size. What this is? This is cation. Cation will be smallest in size and anion will be biggest in size. And atom will be bigger than cation but will be smaller than anion. So the size of anion, cation and atom can be compared this way. Either electrons must be constant or protons must be constant. More the number of electrons, more will be the shielding effect, lesser will be the effective nuclear charge, bigger will be the size. And if more the number of protons, more will be the ENC, lesser will be the shielding effect, lesser will be the smaller will be the size. Smaller will be the size. Fine, smaller will be the size. If shielding effect is less, size will be small. And if ENC is more, then also size will be less. And if ENC is less, then size will be more. Shielding effect will, size is more, so shielding effect will also be more. So this is what they have written. Fe2 plus is 76 pm, Fe3 plus is 65 pm. So as the positive charge increases, number of electrons decreases and size also decreases. So size also decreases. This IR I have written here. What this IR is? Ionic radii. What this IR is? Ionic radii. So this is all about all these points. Then what next is? See here, they have given exactly the size of all these Li plus, Na plus, K plus, Rb plus increasing, and Li plus, B2 plus, B3 plus, O2 minus, F minus, their size decreases. Here it is 134, 90, 82. Sorry, here it is 90, 59. Red is iron, black is this, and red is this. So 90, 59, 41. Then here 126. Then here 119. Here 190. So we should remember this all. What will be the trend? What will be the trend? Here decreasing, decreasing. This also decreasing. 90, 59, 41. So in this way. So red is metal and blue is non-metals. Red is metal and blue is non-metal. So in metals it is decreases left to right, and in non-metals also it is decreases left to right. Now see, and this is 90, 116, 152, 166. So like this you can need not to learn these values exactly, but just to see the trend, whether it is normal or exceptional. If it is decreasing, if it is increasing, then it is normal. But if decreasing, then increasing, then again decreasing, then it is abnormal. So you need to check all such things. So this is all about this all. So this is already done. This all is done. So from here in next class, we'll just go through this all till here it is done. Just to go through this all, just revise
Okay.
this all, and then if you have
Okay.
any difficulty, ask me this all. Otherwise, in next
Okay.
class, we'll start from here and we'll do the remaining periodic properties also. So atomic size,
Okay.
ionic size, 9 properties I told you now. So all that will
Yes, sir.
get over. Fine. Thank you
Okay.
very much. That's all for today. Thank you very much.
Okay. Thank you, sir.
Fine. Bye, Vita. Bye. Thank you.
Bye, sir.